Solving radicals. Solving means that we have some x value that we are trying to determine what it is. When we have radicals, what's the catch with radicals? What can't you have under a square root sign? Can't have negatives, so we're going to have restrictions. So we're going to solve square root x plus 5 minus 3 equals 0. The first two that we're doing have linear functions underneath the square root sign. So right now I have x plus 5 under my square root symbol. So that is a linear function. It's in the form of x plus 5, so it's screw 1. Under the square root symbol. So if we had an x squared plus 3x plus 7 or something like that, then we'd have a quadratic. Yeah. So the first step we have to do is state restrictions. Because we have a variable underneath the denominator, underneath the radical. So if we look at this linear graph on our calculator, just the linear part, y equals x plus 5. We're at 5. We go, I don't know where I was going with that. So 1, 2, 3, 4, 5. We're at 5. We can go up one, right one, or we can go down one, left one, down one, left one, down one, left one, down one, left one, down one, left one. And we're here, right? And that's the equation, that's the line. We agree? What part of this graph is negative y? Anything below the x-axis, right? So this is gone. Why would that be gone? Being that it's under a square root sign now. Because you can't have negative y's. Because x plus 5 is really just the y value, correct? When I plug in an x, I'm going to get the y value. And I can't have any negative y's. We agree? So all the negative y's of that equation would go away. So the only x values we could use are 5, negative 5, and greater. So our restriction is going to be x has to be greater than or equal to negative 5. So if we just look at the equation underneath the actual radical and find all the places where you have positive y values, that's what you keep. Okay? Step 1, state restrictions. Step 2, solve. Before I solve, though, I do a step 1.5. Use my calculator and find the answer so I know where I need to go. So I always have the radical on one side and everything else on the other. So I'm going to technically have square root x plus 5 equals 3. And I'm going to y1, y2. So go ahead and type that into your calculator, y1, y2. Okay, so in our y1, we have square root x plus 5. And in our y2, what do we have? 3. Let me press graph. My window, I'm going to go zoom 6 because I'm in a trig window. And I do second trace 5, enter, enter, enter. So I think I'm going to be finding an answer of 4. We agree? Now, the calculators are good and bad. They're good if you don't mess up typing it in, and they're also good if you use appropriate window. So sometimes you might actually find 2 answers, but you're like, hey, wait a second, I only had 1. What might have happened is your window might not be big enough and you didn't see the other place it intersected, right? So you'd expand the window and see, hey, does this actually exist? If it does, yes. If it doesn't, go back, try again. So right now, I think the only answer is 4. So that's where I'm heading for. Nope. There. Okay. So I'm going to try it out. I think my answer is x equals 4, and I'm hoping that that's what I get. So this way, when you get 4, you're excited. Or say the answer is like 11 over 3, and you're like solving it algebraically, and you get 11 over 3, and you're like, oh no, is this right? And it's just a really weird fraction. Or is it wrong, and I'm totally out to lunch? And then your heart starts racing, and you're like, I think I did it wrong. But you use your calculator beforehand, you get 11 over 3. You solve it algebraically, and you get 11 over 3, and you're like, boom, they match, and you're happy. Totally different feelings, right? So with these, you can always check with your calculator. Whenever you have one variable and an equal sign, you can check with your calculator first before you solve anything, correct? Which would make you feel better when you got your answers. So I square both sides to get rid of my radical. I have to get my radical on one side, everything else on the other. And then I'm going to get the squared canceling up square root, so I get x plus 5 equals 9. Subtract 5. X equals 4. Now, I need to always verify as well. This 4 is greater than my restriction, so that's good. It's in my restricted area. That's possible. But I always have to check my answers, because sometimes you'll get radical answers that actually work and are nice answers, but they're not on your calculator, and you're like, wait a second, like, it's a good answer. It's in my restricted area, so it's good. Why doesn't it work? Because when you plug it back into check, it doesn't work. So you always have to check these with your calculator or algebraically if they ask. You have to check the radicals. So I'm going to check it. I'm going to go square root. And I always check back into the typed version. So 4 plus 5 minus 3 equals 0. Square root of 9 minus 3 equals 0. 3 minus 3 equals 0. 0 equals 0. So I know I'm good. I checked it with my calculator, and I checked it with an actual algebraic method. So you guys are going to try example 2. I want you to solve and state restrictions. You should always state restrictions even if they don't ask you to state restrictions. So I want you to do square root x plus 2 minus 4 equals 0. Then we're going to go into one that gets you a quadratic, but there's not a quadratic underneath. And then we're going to go into where there's actually a quadratic underneath. So try this one out. So for this one, for the restrictions, we look at our graph. What's the important part on our graph that will help us get a number for the restriction? X-intercept. So you go to 2, down, that's 1. So our x-intercept is the important number, correct? What if we don't have it and we want it algebraically? Well, we could just take x plus 2 and set it equal to what? 0 and solve. There's way too many phones out today. Not happy. So what value are we starting at? -2. And what are we going to be? Greater. What if the slope was downwards? That would end up being less than. So x is greater than or equal to -2. We go to solve it with our calculator. What did you guys get? 14. So that's one where it's quite large, right? So you might not have your window set big enough. And you might think, hey, there's nothing. So we're going to go solve it. X plus square root of x plus 2 equals 4. Square both sides. X plus 2 equals 16. Subtract 2. X equals 14. And then we can verify it algebraically. So we can go square root 14 plus 2 minus 4 equals 0. Square root of 16 minus 4 equals 0. 4 minus 4 equals 0. Okay. Now the next one, we're still going to have linear under our sign, our root sign, but we're going to have to do quadratic. So solve square root x plus 5. But now, instead of it just equaling a number, it's actually going to equal a binomial. equals x plus 4. What if it wasn't equal to x plus 4? What if the x was over with the radical? What would I have to do? In order to solve, what do I always have to do? Yeah, subtract over. So I have to have the radical on one side, everything else on other. So I want you guys to give me the restrictions for this one, and I want you to try and solve it. I want you to do this one, and then I want you to try this one. There's one thing I want to go over. We know that this one is the same as that one I showed you before, right? The x-intercept was -5. This is gone. So our restrictions are x is greater than or equal to -5 for both of these, because it's going to be the same thing. But the place where people mess up is they square this side, which is good. And they square this side, which is good. But what I always tell you to do when you have a binomial squared, cross out the 2 and just rewrite it again so you don't forget to FOIL. Do you think they'll have the answer to the x squared plus 16 instead of FOILing it? Yeah. But if you had your calculator, you'd be like, dude, it's not that, because I know it can't be that, right? So x plus 5 equals x squared plus 8x plus 16. It'd be a really good question to say, where's the error? You might not catch it. Move everything to one side. X squared, subtract the x. Plus 7x, subtract the 5. Plus 11. And punching into my calculator, I would have seen that it was crazy decimals, right? Crazy decimals that don't repeat, that don't terminate, scream, I'm going to be put into the quadratic formula, right? Right. Okay. X equals -7. So this is my A. B. C. Plus or minus the square root of 7 squared minus 4 times 1 times 11 all over 2 times 1. -7 plus or minus the square root of 49 plus 44, which is 49 minus 44, which is, oh, that was some really bad math for a second. 5 over 2. Do both work? Do both answers exist? When you type it into your calculator, do you get 2 answers? Which one works? The negative or the positive? So when we type in x equals -7 minus √5 over 2, what do you get? Approximately and then this one, -7 plus √5 over 2, what do you get? -4 point, sorry. Which one works? They're both negative. I was like, you see, my problem was when you guys were saying the negative one. You're meaning the one that the negative in between. I got you. I was like, okay, this one doesn't work. This one does. So if we went to check these in to verify by algebraically, we would legit have to type in the entire perfect quadratic exact value for the x's, right, in order for the left side to equal right side. Okay. Let's solve out this one. So we're going to get square root x plus 5 squared equals x plus 3 squared. Cross that out, write it again. These cancel. I'm left with x plus 5 equals x squared plus 6x plus 9. Subtract x, subtract 5. 0 equals x squared plus 5x plus 4. And then we can do what? factor. So you get x equals -4 and -1. But what do we have to do, even though they work out both really nicely? We still have to check them. Now, if it says algebraically, is your calculator a good enough way to check it? No. Does that force you to not ever touch your calculator because it said algebraically? No, you can still go to your calculator. You can find the answer, make yourself feel better, and then do the math to get you there, right? Also, what's the scary thing about calculators is you operate them. So if you type something in wrong, you might get the wrong answer, and then you're like, but it must be right. But actually, you typed it in wrong. So don't like be stuck to your calculator. Like maybe go back and look at it, see if you maybe typed something in wrong. So we're going to verify it. So I'm going to do x equals -4. Check that. Square root -4 plus 5 equals -4 plus 3. Square root of 1 equals -1. 1 does not equal -1. So this is extraneous. And then x equals -1. -1 plus 5 equals -1 plus 3 as the square root. Square root of 4 equals 2. 2 equals 2. So that one's good. Okay, we're going to do a quadratic under. Yep. Okay. So the first thing we have to do is state restrictions. How do we state restrictions of linear 1? Right. So you drew the graph, you crossed off all the places where the y was negative, and told me where the x's were good, where y was positive. Right? So same thing here. We're going to draw the quadratic. If we use our calculator, we're going to find out that the x-intercepts are decimals, but they want them as exact values. So what's the way we could algebraically find them as exact values? When we have 3x squared minus 5 as my equation. What would I set it equal to? 0 and just solve for the x's, right? Because that's getting me the x-intercepts. And what's my important part? What have we been using the whole time? The x-intercepts to state restrictions, right? Because this is gone now. Because those are all negative y's. So we're going to get 3x squared equals 5. X squared equals 5/3. Square root, what do we have to remember to do when we take the square root of something? Positive or negative. So we get x equals plus or minus root 5/3. So this here is negative root 5/3. This one here is positive root 5/3. So where do our x values exist? Where are they good? When x is less than or equal to negative root 5/3. Right? That's what these are. And then this is all the x values where x is greater than or equal to root 5/3. Does that make sense? That's the difference in the quadratic. So it's a bit harder because you actually have to find the x-intercepts. Often they're not nice, like 2 and 1. They could be though, which would be okay. And then we just solve it like we normally do. The solving is not the horrendously hard part about this. It's the restrictions that are harder. Yeah. Bless you. Sorry? I didn't hear. When there's no sign there, you assume it to be positive. But you could absolutely have the positive root 5/3. You'd be fine. Nothing wrong with that. If the parabola was concave down, our x values would be between them then, right? Between this one and this one. Like if the actual parabola was concave down, if it was like this, then these would be gone. And it'd be between this x value and this x value, right? Not on the outside. Okay. So let's solve. You'd put it into your calculator and you'd see that you're actually going to get 2 answers and they're decimals. So we're going to get 2 solutions and they're crazy decimals. So we're probably going to have to use what? Quadratic formula. So 3x squared minus 5 square rooted equals x plus 4. Square both sides. 3x squared minus 5 equals, cross it out, rewrite it, x squared plus 8x plus 16. Subtract x squared, subtract 8x, subtract 16. It's the quadratic, we move everything to one side. So we get 2x squared minus 8x minus 21 equals 0. And by punching it into my calculator and finding out that it's a crazy, crazy decimal, that's a huge hint to me that, hey, don't spend time going what times what gets me 42 and what plus what gets me negative 8. Negative 42 and negative 8. It's not going to work. I'm going to have to use quadratic formula, right? So at least the answers would give you a hint that, hey, let's try that. So that's my A, my B, my C. X equals negative negative 8, so 8, plus or minus negative 8 squared minus 4 times 2 times negative 21, all over 2 times 2. X equals 8, plus or minus the square root of a large number. $64 plus 232 over 4. 232 can break down into 8 plus or minus root 52, root 58 over 4. And then you can take a 2 out of each. And you're left with 4 plus or minus root 58 over 2. And then we want to check our we want to write what our 2 answers are approximately. So x equals 4 plus root 58 over 2, which is approximately, the little squiggle means approximately, which means you rounded. It's not accurate anymore, it's just approximate. And x equals 4 minus root 58 over 2. Negative 1.81. And when I check them in my calculator, they both work. Your homework is page 96. Three and then 5 to 7. Page 96, 3 and then 5 to 7.